Hello dear students, I hope you enjoyed and learned a lot in our previous lecture of permutations and combinations, that is fundamental principle of counting. Students, we took some illustrations in order to understand fundamental principle of counting. Now in this particular lecture, I am going to move forward. I am going to take some illustrations and then theoretically we are going to progress and understand what is the meaning of factorial notation and what is the meaning of the word permutation or arrangement of distinct or same objects. So let's get started with the topic. Now let us take some more questions that are based on fundamental principle of counting. So first question says, how many 3-digit even numbers can be formed from the digits 1, 2, 3, 4, 5, 6 if the digits can be repeated? Alright, so the question says that we have 6 digits 1, 2, 3, 4, 5 and 6, and out of these 6 numbers I have to form a 3-digit number. Alright, so I have chosen 3 vacant places. I have made 3 vacant places because we have to form a 3-digit number, and that number has to be even. That number has to be what? Even. Now we know that an even number has speciality that its unit digit always contains either 0 or 2 or 4 or 6 or 8. Alright, an even number will be a number whose unit digit will be 0, 2, 4, 6, 8, any one of these. Or we can say that it must end in 0 or 2 or 4 or 6 or 8. Alright, so since we are concerned in finding the total number of 3-digit even numbers, the first priority will be given to place 3. Why? Because in even number we have to first confirm whether the unit digit is an even number or not, or it is ending with an even number or not. Alright, so I am giving the first priority to the third place. So in how many ways third place can be filled? At third place I can keep either 2 or 4 or 6. So basically the third place can be filled in 3 ways. Alright, so third place can be filled in how many ways? 3 ways. Why? Because I have to put either 2 or 4 or 6 in order to make that number as an even number. Now coming to first position and second position. Let us suppose when I was making an even number, I had filled the last place or third place with the number 2. Now since the repetition is allowed, it is given in question that digits can be repeated, it means repetition is allowed. So I can have at this place any one of these 6 numbers. So this place can be filled in how many ways? 6 ways, because I can put over here 1 or 2 or 3 or 4 or 5 or 6. Don't worry about this 2. We have put 2 over here, but the repetition is also allowed. So I can have 2 as many times as I want. Alright, so the first place can be filled in how many ways? 6 ways. And now since repetition is allowed, this second place can also be filled in how many ways? 6 ways. The second place can also be filled in how many ways? 6 ways. Why? Because at this particular place also I can put either 1 or 2 or 3 or 4 or 5 or 6. Any one of these numbers can occur at second position. So the total number of ways of forming 3-digit even number is going to be 6 multiplied by 6 multiplied by 3. I have used multiplication rule because the events have to occur simultaneously. Alright, so our answer is going to be 36 multiplied by 3, which is equal to 108 ways. So the total number of ways corresponding to this particular question was 108. Alright, I hope you are getting the examples and the questions, and your concepts are getting strong with the help of these questions. You should also try to attempt these questions on your own. Alright, let's move to next question. Next question says, how many 3-digit numbers can be formed from the digits 0, 1, 2, 3, 4 and 5, assuming that repetition of digits is not allowed in first part, and in second part repetition is allowed. Alright, so we have two parts of this question. First of all, we have been given the numbers 0, 1, 2, 3, 4 and 5. So we have been given 6 numbers including a 0. And again we have to make a 3-digit number. So I am making or marking 3 vacant places, such that now there is no restriction that you have to form an even number or an odd number or divisible by 3 and so on. So no such restriction. So we can start by filling up the first place. So corresponding to first part of this question, where repetition of digits is not allowed, in how many ways can I fill up this first place? See, at first place 0 cannot be put. 0 cannot be put at first place. Why? Because if you put 0 and then you put 1 at second place and over third place you put 2, it is not a 3-digit number. This is a 2-digit number. So 0 cannot be allowed to enter at first place. So what we are left with is 1, 2, 3, 4 and 5. So for the first place, how many options do we have? We have 5 options. We can fill it up in 5 ways. Alright, moving on to second place. Now let us consider, when I was filling up the first place, let us consider that I filled it up with the number 5. Alright, I kept the digit 5 over first place. So for this second position I don't have 5, but in second position 0 can come. Alright, we can have a 3-digit number like this, 501, which means that at this place even if a 0 occurs, we can make a 3-digit number. So at second place 0 is allowed, 1 is allowed, 2 is allowed, 3 is allowed and 4 is allowed. But 5 is not allowed because I have taken a particular case in which I have kept 5 at first place. Alright, so for filling up of second position, how many options do I have? I have 1, 2, 3, 4, 5 options again. So second place can be filled up in 5 ways. Alright, let us consider that while filling up this place, I kept 4 over here. So now 4 is gone. Now coming to third place, in how many ways the third place can be filled up? So for third place we have 0, 1, 2 or 3. Why? Because 4 has already occupied second place and 5 has already occupied which place? First place. Alright, but at third place we can have a 0 or a 1 or a 2 or a 3. So this place, last place, can be filled up in how many ways? 4 ways. 1, 2, 3 and 4. And in order to fill all these places simultaneously, in order to make a 3-digit number, I have to multiply them. And upon multiplication, I get 25 multiplied by 4, which is equal to 100. So the total number of ways in which 3-digit number can be formed such that repetition of digits is not allowed is going to be 100. Alright, I hope you understood. Coming to second part of this question. Second part says the question is same, just that Now repetition is allowed. Alright, again I have marked 3 places in which first place can again be filled by 5 ways, because again 0 cannot occur over here. We cannot start a 3-digit number with 0. So we are left with is 1, 2, 3, 4, 5. These 5 options are available for first place. Now since repetition is allowed, whatever digit I had filled over here can again be put at second place. So at second place I can place again 0, 1, 2, 3, 4 or 5. I have 6 options in order to fill up second place. Alright, why? Because repetition of digit was allowed, so 1 can occur again, and 0 is already allowed at second place. So second place can be filled in how many ways? 6 ways. And due to repetition allowed, third place can also be filled in how many ways? 6 ways. Alright, so here our answer turns out to be 5 into 6 into 6, which is equal to 30 into 6, and the net answer is 180 ways. Alright, so when repetition is allowed, we are having more number of ways, more number of combinations, that is 180. Alright, let's take another question. Find the total number of 3-digit natural numbers whose at least one digit is 3. Alright, now this is a bit tricky. We have to find total number of 3-digit natural numbers. So again I have 3 vacant places, 1, 2, 3. But the condition of question is at least one digit has to be 3. Among these 3 digits, at least one place must be occupied by 3. It means that I can make a number like 300. I can have a number like 321. I can have a number like 330. I can have a number like 333. Alright. These kind of numbers, total number of numbers have been asked, in which 3 occurs at least one of these 3 positions. Like in 300, we are having 3 ones. 321, we are having 3 ones. In this number, we are having 3 twice. And in this number, we are having 3 thrice. So at least one times the digit 3 must definitely occur. Alright, so a smart way to approach or tackle this question is going to be the rule of bijection. Alright, let's understand what is the rule of bijection. Rule or method of bijection. Since we have been asked that we want a number in which 3 occurs at least one times, let me calculate total number of numbers. Let me calculate total number of numbers, and then from these total number of numbers I am going to subtract number of numbers not having 3 at any place. Alright, so I think upon doing this subtraction I should get the answer of this question. Alright, let me explain what I am trying to say, that we can first count the total number of 3-digit numbers, the total number of 3-digit natural numbers that can be found. Alright, now in that total number of numbers there will be a number like 123, there will be a number like 121, there will be number like 100, and so on. But from these total number of 3-digit numbers, I am subtracting number of numbers not having 3 at any place. I am subtracting those numbers like 100 because it is not having 3 at any place. I am subtracting this number. It means that I am subtracting means I am excluding 121, I am excluding 100, I am excluding 189. Why? Because these are the numbers in which 3 is not occurring, not even once. Alright, so if I subtract these numbers, then I will be left only with those numbers that will have 3 at least one of the 3 places. Are you getting my point? I am subtracting or excluding all those numbers in which 3 never occurs. So what I am left with? I am left with all those numbers in which 3 occurs at least 1. So we can say that at least 1 is equal to total number of cases minus none. Alright, we can use this rule in order to solve this question. So first of all, I am going to calculate total number of 3-digit numbers. Now I have numbers 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now using these 10 numbers, I have to make total number of 3-digit numbers. So in these 3-digit numbers, first place can be filled in how many ways? First place can be filled in 9 ways because 0 cannot occur at this place. Now second place can be filled in how many ways? At this place I can have either 0 or 1 or 2 or 3, any one of these 10 numbers. So second place can be filled in 10 number of ways. Similarly, third place can also be filled in how many ways? It can also be filled in 10 ways. So the total number of 3-digit numbers are going to be 9 multiplied by 10 multiplied by 10, which is equal to 900. Alright, so I have calculated this part. Now we have to work upon this part. Total number of numbers not having 3 at any place. Alright, so please look very carefully and try to understand that we now have to make a 3-digit number in which 3 cannot occur over here or here or here. Alright, so first place can be filled up by how many options? How many options do we have? For first place, I cannot use 0. I cannot use 3 because 3 has to not occur at any of these places. So for first place, I have 1, 2, 3, 4, 5, 6, 7, 8 options. So this can be filled up in 8 ways. For second place, I can use a 0. I can use a 0 over here. I can use 1. I can use 2. But not 3, 4, 5, 6, 7, 8 and 9. So second place can be filled up in 1, 2, 3, 4, 5, 6, 7, 8 or 9 ways. And similarly, third place can also be filled in how many ways? 9 ways. Because at second and third place, we only have to exclude 3. But while at first place, we have to exclude 0 and 3 both. So here we are left with 8 options, here we are left with 9 options, and here we are left with 9 options. So on multiplying these 3, we get 8 into 9, which is equal to 72 times 9. Alright, upon calculation, this is 648. Alright. So I have calculated this part, and in order to solve this question, I am saying that we have to subtract 648 from 900. So the answer is going to be, which will result in 252 ways. Alright, so students, this was a decent question. A little bit of tricky, in which we have used the rule of bijection in order to solve this question. Alright, I hope you must have understood. Now we have to understand a very important notation, that is factorial notation. The notation n factorial represents the product of first n natural numbers. Alright, n factorial, students, simply means, if I write n factorial, this is equal to product of first n natural numbers. So I am going to multiply 1, 2, 3, 4 and so on till the number n, because we are calculating what? N factorial. For example, 5 factorial is equal to 1 into 2 into 3 into 4 into 5. 4 factorial is equal to 1 into 2 into 3 into 4. 3 factorial is equal to 1 into 2 into 3. 2 factorial will be equal to 1 multiplied by 2, and 1 factorial is equal to 1. Alright, so factorial is denoted by this, and if I write n along with this symbol, then it means factorial n. Alright, and it means the product of first n natural numbers. Now, some points worth noting is that 0 factorial by definition is equal to 1. Alright, 0 factorial is to be taken or considered always equal to 1. Also, n factorial can be written as n into n minus 1 factorial. Alright, or it can be written as n into n minus 1 into n minus 2 factorial, or it can be written as n into n minus 1 into n minus 2 into n minus 3 factorial. So in this way factorials can be reduced. Alright, I have reduced this n factorial till n minus 1 factorial. This n factorial is reduced till n minus 2 factorial, and so on. This can be continued further, because if you multiply 1, 2, 3, 4 and 5, or if you multiply them in reverse order, answer is going to be what? Same. Alright, so on the basis of this definition and this notation, let's attempt some questions. So first part is evaluate 7 factorial. 7 factorial implies the product of first 7 natural numbers. So this is 1 into 2 into 3 into 4 into 5 into 6 into 7. Upon calculation, this will result in 5040. Alright. Second part says evaluate 7 factorial minus 5 factorial. So 7 factorial minus 5 factorial can be written as 7 into 6 into 5 factorial minus 5 factorial. Take 5 factorial as common, and we are left with 7 into 6, 42 minus 1. So we are having 5 factorial multiplied by 41. Alright, next part says evaluate 12 factorial over 10 factorial into 2 factorial. 12 factorial over 10 factorial multiplied by 2 factorial. So this can be written as 12 into 11 into 10 factorial divided by 10 factorial multiplied by 2 factorial. 10 factorial gets cancelled out, and we are left with 12 into 11 divided by 2, which gives us 6 multiplied by 11 and is equal to 66. Alright. Fourth part says if 1 by 8 factorial plus 1 by 9 factorial is equal to x by 10 factorial, then find x. 1 by 8 factorial plus 1 by 9 factorial is x by 10 factorial, then what will be the value of x? Alright, so 1 by 8 factorial plus 1 by 9 factorial can be written as 9 into 8 factorial, and 10 factorial can be written as 10 into 9 into 8 factorial. So 8 factorial gets cancelled off from both the sides, and we are left with 1 plus 1 by 9 equals to x divided by 10 into 9. So 10 by 9 is equal to x divided by 9 into 10. Again 9 gets cancelled off and x turns out to be what? 100. So the value of x was equal to 100, corresponding to fourth part. So this is all about the factorial notation, which is nothing but continued product of first and natural numbers. So this is it for this particular class, and we are going to continue in next class.